Alright, a train developed a fault in the lighting system in two carriages A and B. Before the fault, the light intensity in A was I units and the light in B was 0.66 units. At each station the train stopped, the light intensity in carriage A decreased by 17 and in carriage B by 11%. Right, first things first. Let's do A. A starts off at I units, and every station it goes by is, what's it, 0.89. It loses 11%, is that correct? Oh, sorry, 17%. So 17% is you retain 83%, and that's you done there. Cool. B. You start off at 66% of I, and at every station you lose 11%, which puts you at a 0.89 N. Good so far? Now, done. At some point after the initial fault, the light intensity of both carriages is the same. At how many stations did the train stop before this occurs? The train stop before this occurs. Okay. So, what we're going to get here is, we're going to say A equals B, and we're going to log both sides. So we're going to say, and we're, sorry, I won't skip anything. 0.83 to the power of N equals 0.66 I by 0.89 to the power of N. Now, what can you tell me about the I's? What can I do there? Huh? Cancel them? Then what do I do to both sides? Do what? Log. I'm going to lump this together. Why am I allowed to put that two of them together? They're multiplied by each other, aren't they? So I'm going to put them beside each other. Then I'm going to log both sides like so. Now, does anybody remember what log xy is again? Log x plus log y. So log 66 plus log 0.89 to the power of n. Everybody cool with that? Anybody care to tell me what my next step should be? I want to get n on its own, so what should move to the left? I'd say the full thing, would you? Let's move the full thing over, and we'll deal with the ramifications afterwards. So, we get log 0.83 to the power of n minus log 0.89 to the power of n equals log 0.66. Everybody cool with that? Next thing, what am I going to do? Bring the n to the front, don't I? So we're going to get n log 0.83 n, sorry, 0.83 minus n log 0.89. What can I factorize out there? The n comes out, and what am I left with? Log 0.83 minus log 0.89. Now, I could do the division rule there, couldn't I? Is there any need? Any need to do the division rule? Does everybody know what I mean by the division rule? What could I technically, what's log x take away log y? What's log x take away log y? Yeah, it's x over y. I could do 0.83 divided by 0.89. Is there any need though? I just throw it all underneath, couldn't I? And just use my calculator to get myself the answer. So what's n equal to then? Log 0.66 divided by log 0.83 take away log 0.89. And what do we get there? 5.96 is it? Alright. Reread the question. I'm interested to reread the question. Has it reached the sixth stop yet? At 5.96, has it reached the sixth stop yet? I actually think it might have been a fault in the marker scheme. We'll have a look now. Some time after initial fault, the light intensity in both carriages was the same. At how many stations did the train stop? Has to stop. So it wasn't stopped at 5, was it? Has to keep going, so it's close to the stick. It will stop at 6. And it's already happened, hasn't it? So do you get what I'm saying? In between faults, in between 5 and 6, somewhere halfway, somewhere right before 6, the lights became the same intensity. And shortly after that, it pulled up at stop 6. Does that make sense? So I suppose the answer would be, at how many stations did the train stop before this? Stop 6. Fairly poorly worded question. Okay? Now, let's move on to the next one. That's alright with you guys? We'll just stay here for a second. Alright. Now, alright. This clearly taken scan shows you that we're meant to do y equals, lads, we're meant to do y equals the modulus of x minus y. Everybody cool with that? And what's the other thing we're meant to do? Alright, draw that graph. I'm going to draw that graph using GeoGebra, okay? That's cool with you guys? Because I'm not feeling drawing it. Alright, y equals abs. What's x minus 1, is it? Alright. Alright. And many people. What the? No, absolutely. Yep. Nope, not that. Up to right. There you go. How many people got a graph like that? Everybody cool? Perfect. Now, next thing after that. For God's sake, write down the point of intersection. So, he's got it. It says, sorry, what's it saying in the first question again? Just draw it, is it? Find the point of intersection. Did you all write down 1, 0? Yeah. Write down 1, 0, lads. You have to write it down. Otherwise, he can't give you anything. Okay, because it says find the point of intersection. Nextly, on the same graph, plot the line y equals 4. No bother, I will plot the graph y equals 4. Y equals 4. Done. Where's the 2 points of intersection? Minus 3, 4, and minus 5, 4. Is everybody cool with that? So I'm going to use minus 3, 4, and minus 5, 4. Oh, sorry, 5, 4. Minus 3, 4, and 5, 4. Thank you. Okay, so that's your graph there. So 3, 4, and minus 5, 4 for the points of intersection. Minus 3, 4, and 5, 4 for the points of intersection. Alright, use your graph to solve when is it bigger than 4. When is your curve bigger than 4? It says use your graph. Does it say use algebra? No. So when you're using the graph, here's all you have to do. Very simply, x minus 1 bigger than 4. When is the y value of the function bigger than 4? Well, it's bigger than 4 over here, and it's bigger than 4 over here. Any value bigger than 5, any value smaller than 3. And there's a multitude of ways people produce this answer. People did x bigger than 5. People did 5 smaller than x. People did x smaller than minus 3. People did minus 3. Wait. That's one of those days. All right, minus 3 is bigger than x. Yeah, that is right. Now, oh no, not a good one. Now, that's already. Is that right? X smaller than minus 3. Alright, so then some people joined them together. So what did people do? Somebody gave me an answer like this, which is perfect. Well, that's not perfect. Some people gave me this one here. Who did that? I did that. Anyway, happy with that one? Then what about the other one then? How do we do this? Somebody did a less than one. I can't remember. Is it this? That makes no sense. How does that even work? Oh, I see what I did wrong. X5 is smaller than X. That is right. Don't know who did the less than one. It shouldn't work. Here, that's it there. Right? Yes. Which one? The less than. This one here. I said that. The one in the box, perfect. But I got it wrong. All right, we're done.